Mr. Peacock proudly presents Rationalizing Radicals. So today we're going to talk about rationalizing the denominator, but we need to discuss what we call rationalizing the denominator. And so I want you to look at this right here. You see this fraction, 7 over the square root of 5. It is
disgusting.
Now I know what you're wondering. Why? And the reason why is we don't like to have radical functions in the denominator. So how would we get rid of the square root in this fraction? Well, if we take the square root and we multiply it by itself. Now, you need to remember, if we multiply a fraction by something in the denominator, we have to do the same in the numerator in order to change the value of the fraction. So 7 square roots of 3 over the square root of 3 times itself becomes 7 square roots of 3 over 3. And we can say that that is rationalized. All right, so now we're going to rationalize the denominator on a few of these. So all we have to do is look at what the denominator is, at least in this first one, and multiply it by the same thing. Because the square root of 5 times itself ends up being the square root of 25, or just 5. Now the square root of 3x times the square root of 5 becomes the square root of 15x. Now, some people might go, well, can't you simplify? And the answer is, no, you cannot simplify this one. This is as far as we can go. Let's try this next one. All right, so this says to rationalize the denominator, but the first thing I'm actually going to do is simplify, because there's an x squared on top and just an x on the bottom. So that's just going to become 2xy over 3, at which point we multiply by the square root of 3. This becomes the square root of 6xy, and on the bottom, 3. All right, let's try this one. Now, based off of what we've done so far, I would multiply by the cube root of 2, and that is going to be the cube root of 4, which is not actually a perfect cube. So the thing is, you'll notice right here we're saying cube root. That means in order to get 2 by itself, we would have to multiply it by itself 3 times, basically. So we really need to make that times 2 times 2. Meaning, up here, we're going to have to multiply it by the cube root of 4. So this becomes 3 cube roots of 4 over 2. All right, so now we're going to divide if possible and then simplify. So to start with 6x over 3, square root of 6x over the square root of 3. You'll notice they're both square roots, so we can do this, but it becomes square root of 2x, and that's as far as we can go. Let's try our next one. Ooh, this one's fun. So what we're going to start off with is, I'm just going to deal with the k's. There were 3 k's on bottom, which means this becomes, instead of 7, 4. All right, so now let's deal with some of our numbers. The first number I want to deal with is 243. 243 is, well, let's see, I think 3 is a multiple because 24 and 3 are. So that becomes 81. 81 is 3 and 27. Wait a second, 27 is 3 cubed and 3. That means I can pull out a 3, and that leaves a 3. So when I do that, I get 3. I can pull out all 4 k's, but I do have to deal with down here. Now you might notice that this time we're talking about to the 4th power. So since I'm talking about our denominator and it's to the 4th power, that means I can't even just multiply it times 5 times 5. I have to multiply it times 5 cubed, which is 125. So this ends up becoming, as our final answer, 3k cube roots of 375 all over 5. All right, let's try another one. 108 does not, you can't divide 7. You'll get a fraction or a decimal. So that doesn't work, but I can do some of these others. X squared is going to turn this into x cubed. And y to the 6th is going to turn this into y to the, 8th. So at that point, I just have to break down the number 108. 108 is 2 times, I feel like there's probably something better, but I'm not getting it off the top of my head. 54 is 2 times 27. Wait a second, 27, that's a perfect cube. So it looks like we have a 3 out here. We can pull out the x completely, and we can pull out 2 of our y's. But that's going to leave 2 y's inside because we only pulled out 6 from inside. So let's see. Inside, we're left with 4 y squared. And on the bottom, we have to multiply all of this on the denominator by, let's see, we need 2 more 7s, so times 49. Meaning 4 times 49 is going to give us a final answer of 3x y squared times the cube root of 196 y squared, all over 7. Okay, now we're going to talk about the conjugate. A conjugate is an expression that differs from its pair only in the sign of the second term. We learned about the conjugate actually a little bit in lesson 3. We saw this on one of the terms there. But when we multiply a pair of conjugates with the square root as part of the binomial, the radical will cancel out, which once we have a binomial is what we have to do. So let's look. Here's an example of a conjugate. So if I have this original phrase, 3 plus the square root of 5, I can multiply it by its conjugate right here, 3 minus the square root of 5. If I FOIL it out, it becomes 9 minus 3 square roots of 5 plus 3 square roots of 5 minus 5. Here we go. This is the FOILed version. And you might notice this fully cancels. That's going to actually happen a lot, to the point that rather than saying FOIL, I'm just going to say full. So, and we end up getting 4.
Conjugated.
All right. So let's try this out. First, we're going to try this one. Remember, we need the conjugate of the denominator. So 4 minus the square root of 3. And that will be on top and bottom. So on the bottom, to start with, remember, we don't really need to do the outer, and the inner because those will cancel out. But I do need to know 4 times 4 is 16 minus 3, which is 13. Now let's talk about the top. So 2 times 4 is 8. 2 times the negative square root of 3 becomes minus 2 square roots of 3. Minus 4 square roots of 3. And then finally, wrong color. Negative square root of 3 times itself becomes plus 3. Meaning that all becomes 11 minus 6 square roots of 3. And that's our answer. Let's try one more. In this case, we multiply by the conjugate again. So this becomes 3 plus the square root of 7. And we do the same on top. 3 plus the square root of 7. So on the top, this actually just becomes 12 plus 4 square roots of 7. And on the bottom, it becomes 9 minus 7, or 2. Wait a second. That can be simplified. 12 divided by 2 is 6, plus 4 divided by 2 is 2 square roots of, let's write a 7 we can read, and that's it, which means we're done. All right, thank you very much for watching. If you would, please like, subscribe, all that jazz. You know what I'm saying. You can watch other videos on my page, and have a good day.